Hello, I welcome you all to this another interesting screencast, and the problem reads determine the magnitude of the couple force F so that the resultant couple moment on the crank is equal to 0. This problem is coming from the Engineering Mechanics Statics textbook, 13th edition by R.C. Hibbeler. Okay, so we have been asked to determine the magnitude of the couple force F so that the resultant couple moment on the crank is equal to 0. Alright, so let me call this point here. I call this point as my O. Okay, I'll call it as my O. Alright, so we are saying summation of all the couple moments. Okay, then I'll say this will be equal to summation of all these individual forces about point O is going to be equal to 0. We want to find F so that the resultant couple moment is equal to 0. So there are a lot of ways to work out this problem. You can find individual components, like so. You find individual components for each one of these. Okay, you can do this, find individual components and find the perpendicular arms and so on. This and then another one like this, but I'm not going to use this. Instead, I'll just get directly perpendicular arms to this particular member. All right, so let's do so. So I have this point here. Let me use this in black. Okay, where is my black? All right, there we go. This is my black. So that is okay. That is the perpendicular line to this particular member, and we know that this angle here is 45. This is 45, right? So if that is 45, this is also 45, right? Okay, and if that is the case, this is also going to be 45, right? Okay, so if this is 45, then we can subtract 30 minus 45 so that we get this angle here. All right, is that fine? So therefore, that small angle there, we need this angle here. This is going to be equal to 15, right? This is 15. So this one is, that's 45 minus 30. This is 15 degrees. We need that so that we just get one component of this particular force. So we'll do the same also here. We'll do the same here as well. There we go. We come from this point like so. All right, something like that. So we also know again to say this angle here is also equal to 45, right? This is also 45. This is 45. Okay, this is 40. I mean, this is 15. Sorry. So 45 minus 30 is 15. I meant 15. All right. So we'll do the same also here. No, I just want something slim. All right, something like so. So we know that this angle here is this one here. This one here is 45. So we'll be able to get the component of this. We'll map this there like so. Okay. If you wanted, you could have mapped it also the other side like so there. using this angle there, but I will use the other one there. So I'll need to add 45 plus 30, which will be 75, and I'll map it there. And then we have this one, the last but not the least. This one, and then we have like so. So we know that also that this angle here, this angle here is 45. Okay, so I'll map this also here like this. Okay, so with all this information, then we can go ahead, we start doing the mapping. I feel this for me is a little bit faster, but if this is not okay for you, you can get components in your axis like this. Okay, X, Y, and then you need also the lever arms and so on. I'm trying to avoid the lever arms, the tedious work of finding the lever arms, which can be found, not that it's impossible, you can find them. So we'll have a component there. Okay, we'll have one component like so, then we'll have another component like so. Okay, and then here we'll have this component like so. Okay, then we'll have another component like so. Right, then here we are going to have this component like so, then we'll have another component like so. Okay, I'll just draw it up to there. Alright, and then we'll have another component like so. And then we'll have another component like so. Great. So let's label these. So this is going to be equal to 150. This is 150. What is happening? I can't write. Okay. Alright. This is 150. This is 150 sine 15. Then this one is 150 cos 15. Okay, then this one is f. This is f. This is f cos 15, and then this one is f sine 15. All right, and then this one is f cos 75. Then this one here is f sine 75. Then this one is 150 cos 75. This is 150 sine 75. All right, so we have all the information. We take moments about point O. So summation of moments about point O and clockwise being our reference, this is going to be equal to, let's start. So we have a negative moment minus f cos 15 times the lever arm, which is 5. Then we have a positive moment due to a 150 cos 15 times the lever arm, which is 10. All right, and then we have another negative minus f cos 75 times the lever arm, which is 4. Okay, then another minus 150 cos 75 times the lever arm, which is 8, and everything is equal to 0. And if you've seen these components, this one, and this one, they will not contribute to any moment about point O because their lever arms are equal to 0. Great. Their lever arms are equal to 0. Right. So now we have this equation. We can make F subject to the formula. So F therefore is going to be equal to, grab your calculator. So we have minus 5 cos 15 minus 4 cos 75. Okay, and then we have 150 cos 15 by 10 minus 150 cos 75 by 8 divided by answer. We have a 194.09 pounds. Okay, I need to repeat this again to just check if I've made an error somewhere. All right, so let's check once more again. 150 cos 15 by 10 minus 150 cos 75 by 8, everything divided by minus 5 cos 15 and minus 4 cos 75, 194.09. Great. So this is the value of F, which is the couple force, so that the resultant couple moment on the crank is equal to 0. All right, so I hope the video was helpful. And if it was, give me a thumbs up, like my video, continue subscribing and liking my channel. Bye bye, and I'll see you in my next screencast.